to my talk about DSP2JS, C++ framework for the development of in-browser DSPs. I'm Oliver Mayo, and I'm working at the Fraunhofer Institute for Integrated Circuits, IIS, specifically at the Audio and Media Technology department. You might know us for our codecs like MP3 and AAC, but we also make DSPs, transmission systems, production tools, and the like, running on many different platforms, including desktop, mobile, and embedded. That's why most of our code is written in C or C++, and it's sometimes using fixed point and sometimes using floating point arithmetic. Now, I was joining there because I should help them expand their portfolio to the web. And so you can imagine in a company like that, you have many capable DSP developers working on hundreds of C or C++ libraries, but web development not so much. That's why rewriting everything for the web is not an option for us. So we stuck with porting the existing libraries by transpilation, which is especially possible through the advances in Emscripten, WebAssembly, and WebAudio API that we've seen over the last couple of years. So, and the result of that is DSP2JS, our framework to facilitate this task, which consists of a build system. It takes three components that the user provides, which is the binding code written in C++, which is a descriptor file or a description file in JSON format, and a makefile with build parameters. You throw that into the build system and it does its magic, and out comes a pair of JavaScript nodes which contain a functional functional audio worklet that you can distribute to a web developer to make some awesome web apps. Now, as you can see, on the DSP development side, you don't need to know any JavaScript or don't need any web experience, so it's easy to use for web and experienced developers also. It has to be noted that this is currently an internal tool, but we have ongoing discussions about open sourcing this. So let's look into how this works. There's a user which interacts with a web app, and this web app is connected to the audio worklet interface from the WebAudio API. And on the processor side of this, you will find the DSP2JS module, which is compiled WebAssembly that is generated by Emscripten. And this DSP2JS module will communicate with the C++ processor, which can also contain external libraries. It can do this in two different ways. One of which is custom properties, which are handled by the user-defined processor directly. And the other ones, the DSP2JS core functionality, is dispatched through a processor-based class. So to give you a better idea of how this looks like, I have prepared a live coding demo where we will develop a custom gain plugin. And for this, we need to perform three steps. The first of which is write the binding code in C++, for which you have to include the framework first. What's happening? Ah, right. Okay, got it. So you have to first include the framework, like that, and then you have to implement a class, which we call custom gain, which publicly derives from the processor-based class that I mentioned before. And this has to be initialized. Like that. And when you initialize this, you also have to initialize the processor base class, which takes two parameters. One of type data type, where you can choose between different data types that should be provided to you. We choose float32 here. And the second of which is of type interleave mode, because you can also take interleave buffers into this. There you can choose interleaved or sequential. We choose sequential for random reasons. And then you can write your processing function, which just looks like, just looks like that. Right. And it has also two parameters. Those are of type buffer proxy, where you get the in buffer, and the out buffer in. And in the processing function, you will have to cast them into the specified base type, which, as you can remember, maybe, we've chosen float32 up here. So we just cast this to a float pointer. And we do the same for the out buffer. Like that. Now at any point we can query the framework for important parameters, like the buffer length or the channel counts or something similar. And then we just need to add our processing code, which basically has to perform the DSP actions and write them from the in buffer into the out buffer, like that. Now this isn't all too interesting because it doesn't do anything yet. So what we can do is we can add custom parameters. In this case, I've prepared this because it's not too interesting. It's just a float variable called gain with the getter and the setter. And we just multiply the input values by the gain value. And in the end, we just have to expose the class to the Emscripten compiler. I won't go into details here, but you can read all about this in the Emscripten documentation. So that's it for the first part. The second part is you have to write your description file, which is just JSON formatted. It has a name field. In this case, it's a custom gain, which determines the name of the processor later, and an array of members, where each member also again has a name field, which in this case is the gain we want to modify, and a type, which can be data or function. And in this case, we choose data because it's a property that is supposed to be read and written. And in case it's a data field, it also gets an initial value. In this case, it's 1.0. Like that. So that's the second part, and the third part is we write the makefile, where we can give our project a name and show it where to find the DSP2JS framework. We can define some paths. We can give it some additional include paths and external libraries. We also show it where to find the description file, and in the end we include the makefile base from the framework. So we enable this makefile to do all its magic. After that, we can just go to the console and type make, and it will create two files, a node file and a processor file, which can then be distributed to the audio developers, web audio developers. Okay, something's not working. What's that? Right, which is the length of a buffer, right? Just try again. Okay, yeah, no.
Line 22, are you trying to get the length of it?
Ah, right. Get get like that. Okay, now it should work. And it will generate a pair of files, like I said, a node file and the processor file, which are JavaScript files generated by Emscripten mainly, and which will be found in this dist folder that we defined in the make file, which we can see in a second. And those can be given to the web developer to do awesome stuff. So how is this used? It's used by first loading the node file in a script tag or via some import statement, and it gives you access to this DSP2JS global object, which contains all the nodes you have loaded on the site. And then you have to register your audio context with a node, so it can be used in there, after which you can just instantiate it like a regular WebAudio node. So like that, custom gain. And you give it the context. You can connect it like a regular WebAudio node. Like that. And you can adjust all the parameters that you've exposed in the description file. Like in this example, for example, the gain, like that. And that's all there is to it. And after we reload this page in the browser, you can see that it's playing some audio, and you can adjust the gain via this custom gain node. So I hope this this shows a bit of the workflow of how this works, and that you really don't need to know any JavaScript to port these libraries to the web. It's especially targeted towards DSP developers that are not familiar with this kind of setting. And of course, there's a lot more to this framework, which I could talk about, but it would take a bit too long, I think. So I hope this helps, and thank you for your attention, and have a nice rest of the conference.